Good morning, HVAC team. I'm about to cover Unit 74, which is Zone Control Systems. This is for unit or for Module 150. And I also wanted to say congratulations because majority of my Mod 150 class is completing the course today. So congrats, pat yourself on the back. You made it through the entire program, all 9 modules. Technically, Friday is the last day. Now, since we're doing the distance learning, they kind of changed the program a little bit, but I mean, y'all made it. So the only difference is now you have till Friday to turn in all your final work. So that'll be up to you. You can still knock it out today if you want, but yeah, so congratulations on that. That's like, again, that's pretty much all of y'all. I think there's maybe 2 of y'all that's probably still gonna be with me for another month. But so anyway, so let's get into zone control systems. So zone control systems, Unit 74. The objectives are explain the purpose of zone control systems, list the methods used to control excess airflow in a zone system, explain the purpose of variable air volume control systems, describe the operation of a basic zone control system. Also list the components commonly used in zone control systems and explain the difference between a basic zone control system and a communicating zone control system. So principles of zoning. There's different types of zones, 3 zones, split level, zone control for a bi-level house, 5 zone radio system. So there's different ways and different configurations for doing this. 2 zone ranch style house, 4 zone professional office system, individual room zone control system. So yeah, so there's different ways you can set that up. So what a zone system is giving a space the ability to heat or cool individual spaces without, like, basically giving you control over your zone. So if you were to zone your house, for example, and let's say it's a 3-bedroom house and you want each bedroom to be its own zone, plus the common areas will all be one zone. So let's call all the common areas zone 1, and we want all 3 bedrooms to be the other 2, 3, and 4 zones. Total of 4 zones. It's still one AC system operating, and each zone gets its own thermostat. Each of the zone thermostats don't necessarily control the unit. It just opens and closes a damper to that zone, the damper in the duct. So the duct that goes to every different room, if it's not zoned, when the system is on, everybody gets AC. When the system's off, nobody gets AC. In a zone system, when the system's on, you don't necessarily have to have AC. If it's cold in your room and you want to turn the AC off, you can simply turn your thermostat off and it'll close the damper, not allowing any more air into your room. And then the AC is still on to provide air for everyone else who still wants the AC on. And it'll operate until all the thermostats that are connected to that zone board for that system are all satisfied. So if there's 4 zones and one of those zones is on, then that unit is on, up and running full capacity. It's just that all the other dampers are closed, so all the air is going just to that one zone. And when all 4 zones are off, nobody wants air, then the actual system itself cuts off. So that's pretty much how a zone system works. So relieving excess air pressure. So again, if all 4 zones, or let's say 3 out of the 4 zones are satisfied, but 1 is still running, that's going to be a lot of air capacity going to just 1 room. If there's enough air for 4 rooms and now we're only operating for 1 room, that's going to be a lot of air going to that 1 room. So what happens is the excess air pressure has to go somewhere. So that's what they're kind of going to get into right here. So relieving excess air pressure. The most commonly used method to bypass is to bypass supply air. The most commonly used method is to bypass supply air back into the return duct. This is done by connecting what's called a bypass duct. You would literally run a duct from the supply into the return, and there'll be a damper in the middle of that duct, and it'll be a barometric damper, meaning it's not a manual damper or it's not an electronic damper. It operates on a pressure difference. And when there's excess pressure, it'll push that damper open and it'll bypass it all the way into the return. So instead of all that excess air trying to, get forced into one area, that one area is gonna get served, and then the extra is gonna push the damper open and go back into the return. So this is usually accomplished by adding a barometric damper between the supply and return. The pressure difference can be relieved by dumping excess air into a zone whose temperature is not critical. So that would be considered a dump zone. That is a alternative to doing a bypass duct. Instead of running a bypass from your supply to your return, you can just run an additional supply duct somewhere inconspicuous, like maybe in a hallway somewhere where it doesn't make too much difference. So that way, if 3 of the 4 zones are closed and you got 1 open, all the excess air can go, it'll push through that damper and just go out into the dump zone. So that's another way of doing it as well. And when you do that, again, you would use a barometric damper, and if the dump zone is large enough, discharge air thermostats are usually not required. So there's the barometric damper right here. And so there's weights on here. These 4 little discs are weights. You can remove some or add some depending on, the system. And that weight is what'll close it. So when there's excess air pressure, it'll push it. If, enough excess pressure will push that damper open, and then it'll relieve that pressure. And then when there is no more excess pressure, those weights that will allow the damper to drop back close. So that's how the barometric dampers operate. So another approach for relieving pressure is to size each zone duct to handle 60 to 70% of the total system air volume. This keeps the equipment operating correctly and puts the air where the load is. That has some drawbacks though. So it can create problems with the air distribution in the room as the volume of the leaving air registers changes. So does the throw. So the throw is, the distance that the air comes out at. So if the registers are sized for the largest volume of air that will be moving through them, the throw will be too little when when all zones are open. On the other hand, if the registers are all sized for the smaller amount of air, the registers will be noisy and drafty when the full system air volume is going just to that one zone. This arrangement is really only practical on small jobs with 2 or 3 zones. So basically, you can size your ducts to be able to handle 60 to 70% of the total system capacity, but then when you do that, you can throw off the throw. If you size them, if you get registers that are rated for the larger volume, then those registers will be underfed when all systems or all zones are operating. And then if you have registers that are rated for the lower volumes, then they're going to be overfed basically when all the other zones are not calling and there's full capacity on that one zone. It's going to be noisy. So that's the drawback of that type of pressure relief system. I think the dump zone is probably the best way to go if you can, if there's an area where you wouldn't mind using as a dump zone. So anyways, moving on. So parallel and single blade dampers. So these are different kind of dampers. The parallel blade dampers are more for commercial use. These single blade dampers are more residential use. So parallel blade dampers use flat rectangular blades that pivot together in parallel with each other. Parallel blade dampers are often used in commercial systems for controlling the return air and outside air. They are also commonly used in residential applications for rectangular duct dampers. Single blade dampers are commonly used in residential applications and round duct. They consist of a single piece of metal that pivots in the middle. Single blade dampers are mainly used in residential applications. Retrofit and branch duct dampers. Adding rectangular dampers to an existing system requires duct modification. The labor and cost involved can be a deterrent to adding zone controls to an existing system. Retrofit dampers are single blade dampers designed specifically to be inserted into the existing duct. Just move that. They are added by making a slot in the side of the duct, inserting the damper blade into the duct, and then mounting the damper to the outside of it. Most zone control airflow in the trunk ducts. Most zone systems, control airflow in the trunk ducts. This has the advantage of minimizing damper costs since a single trunk damper controls the airflow to several branch ducts. That's cool, but that could be problematic too. This method also keeps air noise to a minimum by placing the dampers away from the point where the air enters the house. The disadvantage of the trunk duct damper is that multiple trunk lines are required. This is more a concern for retrofit applications that not rather than new construction. So trunk dampers, that's cool, probably more so for commercial use when there's, like, let's say multiple areas that'll be controlled by just one area. But like a lot of the times you'll run into trouble with that because, again, the trunk is like the main, and then the branch ducts are the ones that branch off to each individual area. So if there's multiple branches in one zone coming from that trunk, then that's fine. But let's just say in an office building, and you got like 6 offices down this hall, and there's a branch duct or a branch zone that feeds all those offices. Well, then now we kind of running into problems because there's like one person that's probably like the boss who has the thermostat in their office, and when they're hot, they could crank the AC up, and everybody else has to wait till that person is comfortable for before the system turns off. So those trunk dampers, it just depends on the application. You typically want each branch to have its own zone. I guess, again, it depends on the application. Basic zone control system. So here are your zone boards. Ultrazone EWC ST3E zone control is an example of a basic zone control system. The system is designed to work with standard heating and air conditioning equipment. Either mechanical or non-power robbing electronic thermostats may be used. Let me just move that. A single control, sorry, I got visitors. A single control is capable of controlling a 2-zone or 3-zone system. If a greater number of zones are required, controls may be interconnected for additional zones. For more than 3 zones, a slave panel should be used. So this is your zone board right here. These are both pretty much the same thing. This is the actual board. This is a diagram of the board. So I'm going to make this bigger. So this is a 3-zone board. So what you have here is you got your all your different thermostats you would hook up here. I can't really see that. Okay, so there's 1, there's 2. We'll go over here where it's a little bit more clearly marked. So your board in your unit will connect here. So you got your RYWG, all your your typical thermostat wiring setup. So from your board, from the board of your unit to the system section on your zone board, that's where you would make your initial connection. Now each thermostat in your system will connect over here. So you have 3 zones over here. So let's say this is the living room, and let's say this is the master bedroom, and then this is the other bedroom. bedroom number 2. So those are your 3 zones. So that means you have a thermostat in each of these 3 bedrooms. Each one of these thermostats controls this damper. So and it also brings the unit on. So if, let's just go with zone 3. Zone 3 said, okay, it's hot in here, I'm about to turn my AC on. Zone 3 calls for cooling. Boom. The system receives that signal, brings the AC on for cooling. But it's only going to go to this zone because this thermostat's calling for cooling, which means damper number 3 is going to open up and allow the system to shoot air into zone number 3 and cool the space. Zone 2 and zone 1, both of these dampers are still going to be closed because both of these thermostats are not calling. So the system's on, zone 3 is open, zone 3, whoever is in bedroom number 3 is nice and cool, or bedroom number 2, zone 3, he's in there nice and cool, and then no one's in the living room, so that one's off. Person in room number 2 likes to stay warm, so everybody's happy. Let's say, oh, okay, well, somebody came home, now, they want to cool down the living room. Zone 3 is still open, system's still operating at full capacity like normal, and now this damper's going to open. So now the living room's getting cool because this damper's open. So each zone thermostat corresponds with its zone damper. And so all it's doing, so now let's say they leave the living room, they go back outside, dude in the other room is still cranking up the AC. They're leaving, they cut the thermostat off. It's not going to cut the unit off because this guy is still on. So instead of cutting the unit off, when they cut theirs off, this zone damper closes again. This one stays open. This one never opened because this one, they're nice and warm and they like it that way. And this one is still on. This damper's still open. System's still operating. When all 3 thermostats are not calling for cooling is when the system will cut back off. So it only takes one of the 3 for the system to turn on, and then it takes all of them to be off for the system to turn back off. So if all 3 are running, system's running at full capacity. If 2 out of the 3 turn off, system is still running at full capacity until that last one decides to turn off. So that's the idea. That's how the zones work. That's how the zone boards operate. There'll be a place for each thermostat to hook up. It'll have all the typical thermostat wire connections. It's going to have your R, Y, W, G in common for each zone. And then it's also going to have your terminals to connect your zone dampers on each zone. And that's how it works. And then the main control, or the system gets hooked up down here where it says system. That's pretty much how the zone boards are wired up. Let me go back to where we were. So that's how these zone boards work. Moving on, advanced communicating zone systems. So the components continually communicate with each other via a 4-wire connection called the ABCD bus. Commands, operating conditions, and other data are passed continually between the components over the ABCD bus. So these are for more advanced systems where you got more components and sensors and various items on your system. The communication allow for more intelligent system control. Wiring and connections for an infinity zone control system are shown to the right. The indoor unit, outdoor unit, zone control, and damper control are all connected with the 4 wires of the ABCD bus. The sensors are connected with 2 wires, and the damper motors are connected, or the damper motors with 3 wires. So those are the communicating zone systems. And then there's wireless zone systems. One of the newest types of zone control systems uses wireless communication instead of wires. Those I haven't tried those. I don't doubt they work. I just feel a little bit more comfortable with solid wire connections, only because I have that fear of nuisance calls where, they're not communicating right, something went wrong, or customer, there's a user error. Customer might have been trying to program something or whatever. And I just wouldn't want to have those nuisance calls where I have to keep going back and trying to figure out what went wrong. I feel confident knowing that I wired everything up, but that's just me though. I just haven't gotten a whole lot of hands-on with the wireless systems though. So they could be just as reliable as the wired ones for all I know. So a complete zone control system might be overkill if the problem is a single room or area that is overconditioned compared to the rest of the house. This can be solved by using a system with a single zone damper that does not turn the heating or cooling system on, but closes off the damper. Closes off the damper to the room when the temperature is satisfied to prevent overheating or overcooling. So that is the whole point of zoning, is to be able to control a particular area, if not all the areas, at your own free will. So in summary, many zoning products are available for simple relay logic, two-position systems with air bypass to advanced communicating systems with variable air volume and capacity control. A zone system may be as simple as a two-zone system. A zone system may be as complex as a zone for every area in a home with different temperature and setback schedules. So that's how it works, man. It could be as simple as just, the whole house is cool, but I just want my room to be its own zone. Or it could be, a commercial setup where there's offices, common areas, restrooms, all over the place, all on one big system, and they just got it broken off into different zones. So it all depends on the application, the desires of the customer. So that's how zone systems work. I like zone systems. I push them especially for two-story homes, or a lot of the times it'll be empty nesters where they're, an older couple where all the kids are out of the house, and now it's like when the AC is on, it's just cooling a whole bunch of areas that don't necessarily need it. So I've had customers that in that situation where I put in zone systems for them where they only were cooling or heating the area that they were in. It's because, empty nest. But anyways, hope that was helpful. The assignments for this chapter will be on FlexiQuiz momentarily. So study up, use your book in conjunction with this video. The book takes it even deeper than what we just talked about. And so other than that, I will check on y'all later.